At the dawn of the 17th century, the Roman Catholic Church was in crisis. The Protestant Reformation was sweeping across Europe. The Catholic Church was losing entire countries to this heresy, and now it seemed like the universe itself was falling apart. The Church had spent centuries believing that the earth was at the center of the universe. The sun, moon, planets, and stars orbited the earth, embedded in concentric spheres, each one larger than the last, like a celestial Russian doll. Then, in 1543, this fellow Copernicus came up with the wild notion that the sun, not the earth, was at the center of the universe, a concept that came to be known as heliocentrism. The Church tried to stomp out this idea in any way they could. Yet despite their best efforts, heliocentrism was becoming ever more popular. Fools like Johannes Kepler or Tycho Brahe were even expanding upon it, and the Church could do nothing to stop them. Gone were the good old days when the Church could burn people alive for saying things they disagreed with. As a Protestant living in a Protestant country, Kepler and his ilk were forever out of the Church's reach. Unable to silence these mad theories, the Church's only comfort was that no one could actually prove them. Unfortunately for the Church, a fellow named Galileo just happened to be in the business of proving things. Unfortunately for Galileo, unlike his fellow scientists safe in the Protestant North, Galileo lived right under the nose of the Pope himself. Now, what do I mean when I say that Galileo was in the business of proving things? Well, let me give you an example. Imagine you're holding a feather in one hand and an apple in another. You let them both go. Which one will hit the ground first? The apple, of course. From this, you might draw the conclusion that heavy things, like the apple, fall faster than light things, like the feather. This was how most people, with the exception of a few philosophers, thought gravity worked for thousands of years. Galileo rejected this common-sense notion. Our observation of the feather and apple cannot be counted as proof, he would say, because there are too many factors involved. The feather isn't just lighter than the apple, it also has a different shape. If we want to see how something's weight affects how fast it falls, we need to remove all the other factors and just look at the weight. According to legend, that's exactly what Galileo did. He made two balls, completely identical, except that one was made of lead and the other was made of cork. He then dropped those balls from the top of the Leaning Tower of Pisa. Despite the fact that the lead ball was much heavier than the cork ball, they both hit the ground at exactly the same time. This story, if it is true, is one of the first recorded scientific experiments in history. So, what differentiates Galileo's experiment from our observation of the feather and apple? Well, first of all, Galileo was able to separate one factor from another. Instead of saying that apples and feathers fall at different speeds because of their weight, Galileo thought that they fell at different speeds because of their shape. Second, instead of just stating his theory and supporting it with reasoning, Galileo decided to test his hypothesis by conducting an experiment. And finally, his experiment showed that Galileo understood the limitations of human observation. If we simply drop two objects a few feet, our limited senses might not be able to detect if one object fell before the other. They may seem to hit the ground at the same time, because the difference is too small for us to notice. However, if we drop our objects from the top of a tall tower, we can spread out the phenomenon and give our senses a chance to notice even small differences. This was a whole new way of looking at the world. Galileo's method demanded more than observation and explanation. It required an examination of the factors involved and, most importantly, proof. In this sense, Galileo joins the ranks of Francis Bacon and René Descartes as fathers of the scientific method. Galileo applied this new scientific method to the matter of heliocentrism. He would prove, once and for all, that the Earth orbited around the Sun, not the other way around. Yet to do so, he was going to have to build a new tool, something much more challenging than balls of lead and cork. Galileo needed a telescope. Luckily for him, in 1608, a series of Dutch craftsmen had invented the telescope. A year later, in 1609, news of the telescope reached Galileo. The day after he'd heard about the Dutch telescope, Galileo had already built one of his own. The first telescopes were quite weak, only capable of magnifying something to 3 or 4 times its normal size. Galileo gradually improved his technique until he had constructed a telescope 33 times more powerful than the naked eye, thereby overcoming the limitations of human observation. Taking this new tool in hand, Galileo turned it towards the heavens, and the things he saw proved once and for all that the heliocentric theory was right and the old geocentric theory was wrong. One of the first things Galileo discovered were the moons of Jupiter. If the geocentric theory was right, then all heavenly bodies should orbit the Earth. But here were 4 heavenly bodies that orbited another heavenly body. Another thing Galileo noticed was that the planet Venus seemed to go through phases, just like the moon. These phase changes could only be explained if Venus orbited the Sun, not the Earth. Yet another thing that Galileo found was a whole new planet, Neptune, which didn't even show up in the geocentric model of the universe. These findings alone were enough to refute the geocentric model of the universe. But Galileo did not stop there. He also learned that the moon, rather than being the perfect celestial orb that everyone assumed, was in fact pocked with craters and mountains. He discovered that the Milky Way was made of hundreds of millions of stars, packed closely together. This told Galileo that the universe was much bigger than people had assumed. The next year, in 1610, Galileo published his findings in a short treatise called The Starry Messenger. This was the first scientific paper ever published. Galileo's discoveries made him an instant celebrity. Everyone wanted to have a look at the heavens through Galileo's new telescope. Galileo's support for the heliocentric model of the universe didn't even get him into that much trouble, at least at first. However, a few years later, in 1614, the Church decided to take a more hardline approach on heliocentrism. Galileo found himself under suspicion by the Inquisition, and the very notion of heliocentrism was on trial. Galileo made his way to Rome to defend his name and heliocentrism. In the end, Galileo was cleared of suspicion, but he was ordered to keep his mouth shut about this heliocentric stuff. Galileo obediently kept his head down for the better part of a decade. However, when the old pope died in 1623, and was replaced by a new, friendlier pope, Galileo saw the opportunity he'd been waiting for, to publish a new book on heliocentrism. It took Galileo 2 years of pleading to gain permission to publish his book. Some accounts claim that the Pope himself demanded that Galileo include geocentric arguments in his book, as well as heliocentric arguments, much as people today argue for creationism to be taught alongside evolution. Galileo was clearly insulted by the request, for when he published his dialogue concerning the 2 chief world systems, he put the geocentric arguments, the words of the Pope himself, into the mouth of a character he named Simplicio, meaning simpleton. This was too much for the Pope. Galileo was put on trial for heresy. The Church had warned Galileo to lay off the heliocentric talk, and now here he was, defending the heliocentric model and calling the Pope a simpleton for disagreeing. Galileo was sentenced to house arrest, where he would spend the rest of his life. To review, Galileo's impact on Western civilization cannot be overstated. He was one of the fathers of the scientific method, and his experiments were among the first recorded scientific experiments in history. Though Galileo made great strides in other fields, such as falling bodies and even sound frequencies, his greatest impact was in the field of astronomy. Galileo's improvements on the telescope allowed him to see things like the moons of Jupiter and the phases of Venus, which contradicted the established geocentric model of the universe. These findings persuaded Galileo to stand up for the alternative heliocentric model, despite the fact that the heliocentric model was considered heresy by the Church. The Church ordered Galileo to stop supporting heliocentrism. When he did not, they placed him under house arrest for the rest of his life.